Welcome to this new video. So in this video we are going to see how to install local LM Studio, and then how it helps us run local LLMs where we can test out LLMs and also deploy LLMs so that we can use it in other applications as we saw in our previous video. So first, in order to download LM Studio, what you have to do is that go to lmstudio.ai. Then depending on your OS, you can just download the LM Studio for your OS. So since I'm using Windows, so I have already downloaded and installed. Once we install LM Studio, we will be presented with this screen. So in this screen you can see that they provide you a list of options over here, and again these are the same options here. Then we have the popular set of models that are being downloaded in the LM Studio. So we have Llama 3 code, stable code, instruct 3 billion model, then Starling LM 7 billion model, etc. So we have a lot of models over here. So we can download any model which we want, and also we can search for any model which we specifically want. So let us say if I want Code Gamma model, I can just type Code Gamma over here and search. So you will be presented with a list of models that you can download over here. So if I go over here, so I will be presented with a list different set of models. So in this case, the case of Code Gamma, as you can see, we have a lot of models over here. So we need to decide which one to download. So depending upon your GPU capacity, I would recommend downloading a model that fits in the GPU completely. So you can see that they have indicated that the full GPU offload is possible. So I would recommend downloading that model and trying it out first, because when we have a combination of or when we at least run the model entirely on GPU, we get much faster inference speeds compared to running it on a CPU, and it helps in really testing out when the outputs are really long. So what are these different models? So these are nothing but models that are quantized in a different way. So if you want to learn more about quantization, I would recommend checking out the link given in the description. So basically what we are doing is that we are converting the 32-bit floating point number into a fixed set of decimal places, thereby reducing the number of decimal places we are storing, and that helps us in saving the amount of memory it takes for loading that particular weight. So by doing that, we reduce the size of the model significantly. So these are different quantizations. So again, by doing the quantization technique, we also affect the performance of the model, not that much, but up to a certain point. So again, you will have to find the trade-off between the output of the quality and the quantization you require. Now you can download any such model. So the different quantization that are generally available is you can find out by having Q1, then Q2, Q3, Q4, and it goes till Q8. Now so let us say I want to download a Llama 3 model. So these are the popular new model that has been released by Meta. Yeah, so as you can see, I have already downloaded this particular instruct Q4 model, which I can offload into the GPU in a partial way. Now, how can we test such models? So the one way we can test such models is using the AI feature. So this is a similar chat interface to a chat GPT where we can test out our models. Now let us say if I want to load any particular model. Let us just load the model which we want. Yeah. So whenever we try to load the new model, so it has its own set of prompts which we have to follow. So Llama 3 follows a specific prompt structure. Then Mistral models follow a specific prompt structure. So we have to make sure we are following that. So this LM Studio takes care of it automatically by using a predetermined prompt structure where our just user inputs are going to be changed and given to the model. So whenever you change a model, you will get such notification saying that if you want to change to the new prompt system, and you should always click accept just to make sure that you are using the new prompt style that the model has been trained on. Now once we click on that, the model tries to load. Now here, as you can see in the right, we have a set of parameters that we can adjust for this particular model. So let us just wait for the model to be loaded. Yeah, now as you can see, the model has been loaded. So this is the system prompt which we can set over here. So this is the default prompt. So you are an helpful, smart, kind and efficient AI assistant. Fulfill the user request to the best of your abilities. So we can override this particular system prompt of that particular model. Now here we can set the context length. So context length is nothing but the total length of the input and output the model requires. So this Llama 3 model has an 812 token context limit, so we can test or decide our own context length. So the smaller the context length, the lesser memory we generally require it. So if you are having a very large input, I would recommend increasing the context length up to the 8192 tokens, or you can use a lower token count for lower input scenarios. Next, we have the temperature. So temperature determines the what you can say the randomness of the generation, and it increases creativity. At the same time, it increases the hallucination effect of the LLM models also. Next, we have the tokens to generate option. So we know that the model generally has a output token limit of 4096 tokens. Now let us say if I want to restrict the model to just 100 tokens, I can just put 100 over the here to restrict the model to give output of only 100 tokens. And if I give -1, it just indicates that I want the model to decide when to end. So generally I would recommend keeping -1 as it should give us the complete output, not randomly stop in between. Now we have some inference parameters. So we have some top sampling techniques, repeat penalty, minimum sampling and top p sampling. So these are majorly related to the outputs and how it is going to predict the next token. So once you generate any particular answer, I would recommend you to tinker with these particular hyperparameters to see how this particular output changes. Next, we have the GPU setting. So here we are offloading close to 10 layers of our model onto the GPU. So this makes sure that this particular 10 layers runs much quicker than what our model can on our compared to the CPU. So I can also increase this to particular set of layers. So if I click 24, I can just reload that particular model over here. So I know because previously I've tried, I can offload up to 24 layers onto the GPU. So I would recommend you running different set of layers to offload maximum number of layers onto the GPU. So you can also set it to max, but when you set it to max, it will ask you for a prompt saying that if the model is going to fit in that particular model or not, in the GPU or not. So if the model is not going to be fit onto the GPU entirely, it will show you a warning like this. So I would always recommend loading only the set number of models that are possible onto the GPU, so that we don't go into the cache system of the GPU that generally Windows have, because it is much slower. Now, once we offload the layers onto the GPU, we have certain prompt style which they are using. We can also modify this, but I would recommend not to do so until you find the output not very say reliable or not up to your expectation. And also one thing to notice that the entire LM Studio uses a Llama CPP library to offload and run the models locally. Now let us say if I want to start a chat with that particular model, so I can just type any message. So while typing the input, you can see the amount of tokens you are going to need also over here. So as you can see, it start generating the answer for whatever question you have asked. So once the answer is generated, we get some very useful metrics which we want to take care of. Now the first metric which we want to look at is first time to token. So it indicates how much time it took for the first token to be generated. Next, the total generation time it took to give out the complete answer. Next, we get the speed of token generation. We are able to see that we are able to generate close to 8.3 tokens per second. And next, why was the particular output stopped? So we found that the end of statement line was found. That is, the model decided this should be the end of the particular answer. Next, we find the number of GPU layers offloaded, number of CPU threads used, and the token count we used. So we can see that out of the 3024 token context limit, we use close to 356. So this is some metrics which we want to monitor, because we are actually trying out LLMs for any particular Gen AI case, right? So when we look at these metrics, we get an idea which LLM to use, how it will perform in a real-time scenario, how much fast it will give us the particular output. Now let us say if I go for a much smaller model, say a model called as 5.3 that has been released by Microsoft, but that has been trained on synthetic data rather than the complete data that say models like Llama 3 uses. Now what we can do is that we can ask the same. So since it is a much smaller model, what I can do is that I can completely offload this particular model onto the GPU, because it's the entire size of the model is only 2.39 GB. So since I have a GPU that has a VRAM of 4 GB, I can entirely offload the model onto the GPU. Now let us type the same answer question over here and see what it does. So as you can see that the output is much faster and much quicker in this particular case, because now since the model is now entirely running on the GPU, all the parameters that we usually like previously monitored will be much better. So as you can see, the first time to token has been reduced to 0.33 seconds. Now next, which was previously close to 40 seconds. Next, we have the total generation time, which again was around 43 seconds. Now it has been reduced to 12.8. Next, the speed of tokens, as you can see, has been increased from 8 to 42. And we can see the other number of layers and the total context output we had used for this particular case. So as you can see, since allowing the models to like entirely run on GPU will give us much quicker and better results based on my experience. So this is how we can test out different models. So next, we look at some of the other features the LM Studio provides us. Next, we have a playground session where we can test multiple models simultaneously. So in this particular case, what we can do is that we can load multiple LLMs onto the same system, then type the same output and look for the output and see which output is better and compare it one-on-one. So what this helps us to do is that it helps us to quickly filter out the models which we want to use by testing out which is the best model against the new model which we want to try. And this really helps us reduce the time it takes to find the right model for our generative AI use case. So in this particular case, we can set some custom instructions and output format we want, either the JSON mode or any particular JSON schema which we want to use. Then we can select whichever model which we want to load. This is where we type the input prompt to run all the particular LLMs. Again, what I would recommend is that first you try with small 2 LLMs that can entirely fit on GPU so that we can compare the performance. Then when we go to much larger models, it becomes a issue. Now we come to the feature which we previously saw in our previous videos, where we used the local inference servers feature of the LM Studio. So we can load any particular LLM and set up an endpoint that we can directly use in our Python or any code which we have that can connect to this particular LLM and run send input and get output, basically how the OpenAI server or API works. So we can set up the same kind of server over here, and it uses the same format of the OpenAI API's structure, so that we can use interchangeable code with them. So as you can see, they have also provided a simple example of how we can use this particular model in the same OpenAI's case. So usually we load the OpenAI and then give the base URL and the API key. Then we give the model name and the system message, the user message, and let the allow the LLM to complete. So it kind of follows the same thing, just the base URL and the API key changes in this particular case. Next, we have the My Models option. So in My Models option, we can see that we can see the list of models which we have previously downloaded and where they